all. I, Dr. Indu Prabha Singh, Professor, Electronics and Communication Department, Shri Ram Swarup Memorial, College of Engineering and Management. I am here to deliver the lecture on electronics measurement and instrumentation. So, we will in this subject we will cover the electrical measuring instrument, that is PMMC instrument, application of PMMC instrument in electronics instrument like CRO, DSO, multimeter. Then we will discuss the bridges for the measurement of resistance, capacitance and inductances, and then we will discuss the transducers. So, this is the first lecture. Here I will discuss the concept of measurement. So, this is the outline of my presentation. The first I will discuss the measurement system, then characteristic of instrument, methods of measurement, measuring standards, error in measurement system, and then measurement error combinations. So, first I will discuss what is measurement. So, before going to measurement system, I will discuss what is instrument. So, instrument is a device that is used to determine the present value of any quantity under measurement. And what is measurement? Measurement is the process of determining the amount, degree or capacity by comparison with the respected or expected standards. So, then I will discuss what is the measurement system. So, we will understand this measurement system by one example. Suppose we want to measure a temperature of any oven or the boiler of any industry, and the person who is measuring the temperature is at any place which is not the at the boiler place. So, it is either at a remote place or he is located at some central place of that industry. So, then he required a device that measures the temperature. So, there is a sensor quality to be measured, suppose the temperature to be measured, then there is a sensing element. So, that sensing element basically is our either it is a thermocoupler or the thermistor. So, by thermocoupler or thermistor we can measure the temperature. Then that device will sense the temperature, then we have to transmit that temperature to that person. So, for this we need to convert this temperature into electrical signal. So, we need a variable conversion device. So, that device will convert this temperature into electrical signal. So, the combination of this sensing and variable converging element is known as transducer. It means we need a transducer, and transducer is a device which converts one form of energy into another form. Then we need, then the output of that transducer is either very low in amplitude, like it may be of the range of microvolt or millivolt. Then we have to increase the amplitude of that signal because it is transmitted to that person. So, it is transmitted either through the wired network or without or through the wireless network. So, we need some amplifier to amplify that signal, or if that signal consists of noise signals. So, we need to remove that noise signal. So, for the removal of noise signal we either need filter circuits or we need the low noise amplifier. Though the amplitude of that signal is increased, and then this is known as variable manipulation element. So, it may be a low noise amplifier, it may be filter, or it may be amplifier circuit. Then we need to transfer the data, that is through the data transmission element. It may be a wired network, it may be a transmission line, or it may be wireless network. We can also transmit the signal through the wireless network, that is through the internet. So, we need those circuits to transmit the signal, and then at the receiving end we need to convert these electrical signal into temperature, because the person want to read the temperature of that oven. So, for this either we need a transducer or we need an instrument. That instrument is calibrated in terms of temperature. So, it means it is receiving electrical signal, but it will show the temperatures there. Then classification of instrument. So, instrument may be classified into 3 categories: mechanical instrument, electrical instrument and electronics instrument. Mechanical instruments are very much suitable for the measurement where we need a stable inputs. So, and the problem is with the mechanical instrument that they are having a moving part, and the moving part having very high mass. So, because of high mass there is an inertia loss. So, we will use only the mechanical instrument at that place where we need a stable measurement. Then electronics, we can see the example of mechanical instrument, that is vernier calipers. Then there is an electronics instrument, we will study electronics instrument later on. Then electronics instrument, basically you can see this is the electronics instrument, and this electronics instrument basically represent the values generally in the digital form. So, electrical instruments are again classified into 2 categories, one is absolute indirect and second is secondary instrument. So, absolute instruments are basically used to measure the absolute values like mass, length, etc. And then secondary instruments are used to measure voltage, current or other things. So, again we can divide it into 2 parts, one is analog instrument and other is null detector. So, null detector circuit is here. So, in null detector what we do, we suppose we want to measure the unknown EMF, unknown voltage, then we place the unknown voltage over here, and there is a sliding circuit, this is your rheostat circuit. So, and the known voltage, the standard voltage is placed over here, and then we move this galvanometer. When this galvanometer shows 0 value, then the value of this unknown voltage is equivalent to the known voltage, and in this way we can calculate the voltage through this null detection, null deflection circuit. Then next is deflecting instruments. So, deflecting instrument again divided into 3 types. One is indicating instrument, integrating instrument and recording instrument. So, indicating instruments are like this PMMC instrument or galvanometer is type of indicating instrument. In indicating instrument there is a scale, it may be linear or non-linear scale, and then there is a deflecting needle. So, pointer will move on this scale, and the deviation of pointer from 0 to that place is the theta, angle theta, and this theta is proportional to the unknown quantity. So, by this way we can measure any instrument, any physical quantity by using indicating instrument. Next is the integrating instrument. So, integrating instruments are basically those instruments in which we want to measure the quantity for a time period, like our energy meter, where we want to find out the the power absorbed by the home elements. So, that is the integrating circuit. And recording instrument. Recording instruments are those instruments which are used for the recording purpose, like this way. So, there is an stylus and there is a plain paper. So, stylus is moving on the plain paper, and this will show the instantaneous value of that variable quantity. Then characteristic of instrument. If we are using an instrument, if we are using instrument by measuring a signal or any unknown physical quantity that is not in variable in nature, that is not rapidly varying, then we use the static characteristic of that signal. But if the physical quantity that we want to measure and it is rapidly changing, then we will consider the dynamic characteristic of that signal. So, in static characteristic we will see the accuracy, precision, sensitivity, resolution, static errors. So, what is accuracy? Accuracy is means we are taking so many readings and how much that measured value is close to the true value. So, closeness of measured value to the true value is the accuracy of that instrument. Means suppose we are measuring any voltage, suppose the voltage is 1.74 volt. Okay. So, 1.74 volt, suppose one instrument is measuring at 1.71 volt and the second instrument that we are using, it is measuring it like 1.63 volt. So, this instrument is more accurate with respect to this one. So, accuracy means how much close the measured value to the true value. Then second is precision. So, what is precision? Precision is basically the closeness of the agreement in between the repeated measurement. Means suppose we are measuring 3 or 4 times an instrument, then how close these values are there. So, that is the precision. Suppose we can understand this by this diagram. Suppose this is the target and we are using this target. So, as we can see, we have taken more measurements, more than one measurement. So, all the measurements are on the target. So, it means this circuit, this target is having high precision and high accuracy, because they are also on the target and they are very close to each other. So, this is measurement is having high accuracy and high precision. But when we see this diagram, so here what will happen, all the measurements are close to each other, but they are not close to the target. So, it has low accuracy and high precision. Then we see here, this is again all the measurements are close to the target, but not very near to each other. So, this type of measurement is having high accuracy, but low precision. Then if we see this, neither they are on the target nor they are very close to each other. So, this is neither having accuracy nor having precision. Then next is sensitivity. So, sensitivity is basically the change in output to the change in input is known as sensitivity of the instrument. So, here we can see that sensitivity is change in output by change in input. Then resolution. Resolution means ki the smallest quantity that is detected by any instrument. Suppose an instrument display in digital and it is suppose displaying 1.43 volt, means it is using 2 digits after the decimal point. So, the resolution of this instrument will be 0.01 volt. Okay. So, this is your resolution, that is the minimum smallest quantity that is detected by the instrument. Then static error. Static errors are basically the difference between the measured value and the true value. So, static error, we can see static error is Qt minus Qm, where Qt is the true value and Qm is the measured value, and we can also find out it in the percentage of static error. So, it is Q2 minus Qm by Q2 into 100%. Then dynamic characteristic. Dynamic characteristic we are considering when we are measuring an instrument, measuring any quantity that is varying very rapidly. So, the first is the speed of response. So, speed of response is the speed at which the instrument responds to change in the quantity to be measured. So, if the quantity is changing very fast and the measuring instrument speed is less, then it will not follow the input in proper way. Fidelity is the degree to which an instrument indicates change in the measured quantity without any dynamic error. And next is lag. Lag means the amount of delay present in the response of instrument for change in the quantity to be measured. Then dynamic error, the difference between the true value and the measured value is dynamic error, like static error. So, if we see this diagram, then this is the actual value of the quantity to be measured and our instrument is showing this value. So, the difference of these two values are the dynamic error. Okay, this is the instrument reading and this is the dynamic error, and the instrument response take this time. So, this time is known as dead time. So, now we can solve a question based on this, that a thermometer is calibrated 160 degrees centigrade to 200 degrees centigrade. The accuracy is specified within plus minus 0.2% of the instrument span. What is the maximum static error? So, span of instrument is 200 minus 160, that is 40. So, maximum static error will be 0.2 plus minus 2% of the span. The span is 40. So, it will be 0.2 into 40 divided by 100. So, the maximum static error of this instrument will be plus minus 0.08 degree centigrade. The second question is, a voltmeter connected across a resistor gives a value of 35 volt, but the expected value of resistor was 36 volt. Find the absolute error and the relative accuracy of the instrument. So, absolute error means the actual value minus measured value. So, actual value is 36 volt and measured value is 35 volt. So, the error will be 1 volt. Relative error, the absolute error, that is the difference between actual value, true value and the measured value divided by the actual value into 100. So, it is the error will be 2.77%. Now, the relative accuracy is 100 minus this percent, that is 97.22%. Now, standard of measurement. As we know, the measurement is basically the comparison of any physical quantity with the standard one. So, we need standards to measure any values. So, standards are basically the physical representation of a unit of measurement. So, these are used to determine the physical quantity by the comparison method. So, generally we are using the comparison method for the measurement of any physical quantity. So, instruments, these standards are of 4 type. First is international standard, then primary standard, secondary standards and the working standards. So, international standards are basically defined by international agreement, and these standards are maintained by International Bureau of Weights and Measures Paris, and these are periodically evaluated and checked with the fundamental units of physics. Then second is primary standards. So, primary standards are basically placed at national standard laboratories of different countries. India is also having national standard laboratory at Delhi. So, these are maintained by the national standard laboratory and they are not available for the general public or for the industries. So, and they are calibrated and verified, they are used for the calibration and verification of the secondary instruments. So, secondary standards are basically it is kept in the laboratory, and by this we calibrate the working standards that we are using for the measurement purpose. So, secondary standards are reference standards used by the measurement and calibration in any industry, any laboratory or any we can use at our college level laboratory also. So, industry periodically sends these secondary instrument to national standard laboratory for the calibration and comparison. They are compared against the primary standards and then they will issue a certificate that yes, this instrument is calibrated and the performance is as per norms. Then periodically we have to compare our working standard which we are using in our laboratory to these secondary standards. Then methods of measurement. So, there are only 2 methods, one is direct method and other is indirect method. Direct method may we are not using any mathematical calculation and we measure the quantity, physical quantity by the instrument directly. So, these are we can measure the voltage, current or resistance, the distance the length of any cloth or other things. So, that we can measure by the direct method. In indirect method there are some measuring things, there are some physical quantity that we can't measure with direct method. So, that is the speed. So, speed we can measure with the calculation of the distance and the time. So, error when we measure any physical quantity by any instrument, then there is again a deviation from the true value. So, that deviation is known as error. So, error may be classified into 3 categories: gross error, systematic error and random error. So, gross error are generally man-made error. So, when a person who is using the instrument, he is not familiar about the instrument, then he may create some error. Second, suppose a person is reading the value, suppose a person is measuring voltage and suppose he is the reading is 1.43 volt, but carelessly he record it like 1.34 volt. So, this is the human made error and this is your gross error. So, gross error can be removed either by train the person or by taking more than one reading and taking 2 or 3 readings, 3-4 readings and then taking the average of all that. So, by this we can remove the gross error. Then random error. Random error may happen due to unknown reason, maybe sudden change in temperature, sudden change in voltage and all these things. So, random error we can't control. Then there is systematic error. Systematic error means error which occur in every measurement. So, systematic error can be divided into 3 parts. One is instrumental error, environmental error and observational error. So, observational error are basically happens when it is due to the parallax error. Suppose this is an instrument scale and this is the indicator. So, suppose if we read this value in straight to this position, then it will give right value, but if we see from this location or this location, then it will give different value. So, that is the observational error. This is also called parallax error. Then environmental error. Environmental error deviation from the true value can be caused due to the change in environment. Change in environment means change in temperature, moisture and due to the stray magnetic field. So, if we use our instrument in that locations, then the environmental error will happen. Instrumental error is also caused by loading effect, misuse of instrument, inherent shortcomings of instrument. So, inherent shortcomings of instrument means the instrument, suppose we are using a PMMC instrument. So, there is a permanent magnet. So, as the time span, then the magnetic property of the instrument, that permanent magnet will also change. Similarly, we are using a spring. So, spring property may change with the time. So, these are the inherent shortcomings of the instrument and misuse of the instrument, that not proper upkeeping of the instrument, or there is some not proper handling of the instrument. Then loading effect. Loading effect generally happens in the voltmeter like instrument. Suppose the voltmeter is having a very high resistance, and if we measure a voltage across any resistance whose value is less, then the resistance of the voltmeter and the resistance of that circuit will come parallel to each other and the total resistance will decrease, and so the output of that voltmeter will not defining the proper value. Then if we use 2 or 3 measurements, suppose we are using 2 resistance and we connect these resistances in series, then the error of both the resistances will sum achieve. So, what will, if we consider 2 quantity, here we denoted as A and B. So, if we are considering 2 quantity A and B, and if measured value A is equal to A plus minus delta A, there is tolerance in every quantity. So, the tolerance is suppose delta A and the second resistance having a tolerance of delta B. So, maximum error in sum and difference will be delta A plus minus delta B. Similarly, if we suppose we want to measure the voltage and we have to measure current and resistance. Suppose we are not having the voltmeter, then we will measure the current and the resistance. and then we will add product the current and voltage, current and resistance, and then we will get this. So, this will the error of a product and quotient. So, it will be delta z by z is equal to delta a by a plus delta b by b. Similarly, if it is raised to the power a, then it is a square, and at that time the error will be delta z by z is equal to 2 delta a by a. So, this is one question. Suppose the resistance R 1 is equal to this. The question is 3 resistance are following ratings, the ratings are given. So, we have to calculate the limiting error. So, here the R 1 is equal to the 35 ohm plus minus 5%. So, it is 35 plus minus 5 by 100 into 35. So, its value will be 35 plus minus 1.75. Similarly, R 2 and R 3 we have calculated. Then the limiting value of the resultant resistance R is equal to, we have segregated this and tolerance part there. So, it will be 160 plus minus 8 ohm, the magnitude of resistance is 160 ohm and error is plus minus 8 ohm. Then we have to calculate the percentage limiting error, then it will be plus minus 8 by 160 the total resistance into 100, then the error will be plus minus 5%. Thank you for this lecture, and next lecture I will cover the PMMC instrument. Thank you all.